Now that we have the vehicle in a semi-drivable state, let's display the speed on our user interface. In order to do so, we need to add a Text Mesh Pro object to our scene, much like we did with projects before. So in the hierarchy, I'm going to right-click in the empty space, go down to UI, and go to Text Mesh Pro. Since I haven't added Text Mesh Pro to this project before, I'm going to need to import it. Now that it's imported, I can exit out. So now we can see in our scene, we have our vehicle, but we can see the white outlines of this Text Mesh Pro canvas. So I'm actually going to select that canvas and press F. So now it zooms out so I can actually see very far zoomed out. So if we get our canvas in frame here, you can see our little game world here in the corner. And then we have our Text Mesh Pro canvas here. So if I press play, you should see that little new text pop up, probably on the bottom, right about there. So that doesn't look good at all. So we're going to have to actually adjust that. So first what we're going to do is with the actual text, we're going to rename this to our speedometer. And we want our speedometer to have probably a position in the top left where our player can see how fast they're going. So first I'm actually going to change the anchors to be the top left. And now I'm going to move the text over to that corner, right about there. And then for the text, I'll just say speed for now. Now if I press play, we should see speed in the top left corner. Cool, so that looks pretty good. Not going to change any of the text for now, for the fonts or anything like that. I'm just going to leave it as is. In this case, since we just want to see our speed working, we're not going to use a game manager script. I'm actually just going to use my player controller script, since that's where I can actually see the speed that our player is moving at. So in the player controller script, I actually need to create a variable for that Text Mesh Pro text. So in fact, I actually need to import that library first. So at the top of my script, I add a using statement for using TM Pro. So now I can find the Text Mesh Pro library. I'm going to create another serialized variable like this game object. This time I actually need the actual text. So I'll get the Text Mesh Pro UGUI and call it speedometer text. So now that I have this variable, in Unity, actual text. So I'll get the Text Mesh Pro UGUI and call it speedometer text. So now that I have this variable, in Unity I need to make sure that I actually attach this text to the speedometer text. So I'm just going to click and drag on speedometer and drop it in there. So now we have a reference and I can change the text when I need to. Now the question is, how do we actually calculate the speed of our vehicle? Once again, we'll head over to the internet and see if anybody has any questions for us. So I looked up calculate vehicle speed. And one of the first answers is how to get car speed. That seems like what I'm looking for. So let's see, this person has a car that can move and they want to get the speed. Okay, so it says here, so for car speed in kilometers per hour is speed. So I guess we need a speed variable again. We set that to the magnitude. So we can actually get the velocity that our rigid body is moving. So that's very helpful. And then in this case, they multiply 6. That's a pretty good start. So we can actually just use this rigid body.velocity.magnitude. And velocity will actually get us the actual velocity, the speed that our vehicle is moving. And the magnitude gives us the number. So that was pretty helpful. I did notice as I was going through the results that there is another result about a car with wheel colliders. We do have wheel colliders, so let's just see what this person says. making a simple car driving game with the GUI text. Cool, that's exactly what we're trying to do. Speed display doesn't seem very realistic. This person has this little formula here. Let's see what the reply is. We simply get the speed by using, there's that rigid body velocity magnitude again. Oh, so it returns the speed in meters per second. So that's what you get when you're using velocity. So to get the speed in kilometers per hour, oh, so you multiply by 3.6. So that's why the 3.6 was there. If you want to get it in miles per hour, multiply by 2.237. Oh, okay. So because when you're going from meters per second to kilometers per hour, you have to do a little bit of math to get the proper number of how to convert meters per second to kilometers per hour or miles per hour. So that's actually what those numbers are. Don't need to do calculations using wheel climbers. Okay, cool. That's pretty helpful. So since it said we needed to make a speed variable before, I'm actually going to uncomment out our speed variable. I'm actually going to turn this into a serialized variable as well. Since our speed is actually being calculated now, I don't actually need to set it when I start. Now, in my update method, I probably want to calculate my speed after I apply that force. So if I do speed equals player rigid body dot velocity dot magnitude, and we want to times it by 2.237 f. That way our program knows that that number is a float, just for our own sake if we want to change it to kilometers per hour. So for kilometers per hour, change 2.236. Okay, so now we're getting that actual speed. So now we just need to actually set the text for our speedometer. So if we use speedometer text dot set text, we need to make a string so we can say that this is the speed, and then we concatenate the actual speed that we're calculating, and then just as a nice touch we'll add another string at the end to say miles per hour. So now if I save this, hopefully now our speed should update in the top left when we play our game. Okay, well that's very weird. My speed is moving very fast. I think I actually still have my vehicle set to be very heavy. Change that really quick. 2,000, I believe it was 1,000 before. Let's see, so now we play, and we can move down the road. And there you go. You can see it's changing. There's a lot of numbers after the decimal point. In fact, when we press play, you can see that it actually starts giving us a number value because it's falling to the ground. So that doesn't look right. Also, it's kind of small. We should probably make that a little bit larger. But let's fix this problem first because this looks very weird. There's all these decimals. So how do we get rid of these decimals? Well, the decimals happen because this number is a float. And to get a round number, we actually need an integer. So how do we get an integer? So let's head back over to the internet and see what it has to say. I looked up how to convert float to integer Unity. The first result that popped up is this f round to int. So returns f, so that's float rounded to the nearest int. So float f, so that's the number we're passing in. And then it gives you back f rounded to the nearest integer. Okay, so it looks like this is how you would use it. So math f dot round to int, so then you put in the float, and then it gives you 10. Okay. So math f dot round to int. Well, let's see if that works on this little formula that we have here. So I'm actually just going to apply this here. So let's see, math f dot round to int. And I guess we just want to put this entire number now if we save, so now we should just get whole numbers. There you go, just says 0. Probably make that text box a little bigger. There you go, now it's just whole round numbers. That's good, that works great. We'll fix that issue with the size later, but that works. For a fun little fact, if you remember a few lessons ago, we were talking about different keywords you could use on variables. Things like const, read only, and static. You can actually see we have a const variable here for our turn speed. And this is actually down here where we're calculating our speed, a case where you can actually see a static class. Actually, in fact, up here as well. And so if you remember, in cases like our rigid body, we have to actually Another cool feature that a lot of car simulators have is a display of the RPM, or revolutions per minute. The tricky part is figuring out how to calculate it. First, what we need to do is create a new text area for our RPM. So in my canvas, if I left click on that little drop down arrow, so we have the speedometer here. I need to right click on canvas, and I'll create another UI text mesh pro. Now it's somewhere off in the distance. Let's see if we can get, there you go. So you can see it's in the center of our canvas here, and we need to actually move it to the top left, about here. I'm actually going to set the anchor first, so it's in the top left. Then let's see, what line is that at on the Y? X is 135, so I think we just move this over. There you go, so it's all lined up, so that looks nice and clean. And here we'll change this to RPM. To avoid that problem we had with the speed before, with wrapping, we're going to set this to disabled. And now we can get our RPM. Let me make sure that I rename this element to the RPM. Now I need to actually create another variable for this. So in my player controller script, right after the speedometer text, I will create a new serialized field text mesh pro GUI. We'll call this RPM text. And now I need to make sure that I set the RPM as a reference. So in Unity, if I select my player, I'll drop this RPM text element down into the RPM text. So now we have the RPM text, but we need to actually calculate the RPM. So let's see what we can do. So the internet will be another helpful resource here once again. So here we need to calculate the RPM of our vehicle in Unity. So we have all of these different options. We'll check out this Unity answers question. So this person is making a speed limiter. Wants to do this through wheel collider.rpm. That could be interesting. Problem is we would have to get a reference to one of our wheel colliders and then see what that does. Let's see what this person says. If you want to get the speed, you should know the circumference of your wheel. Multiply it. Okay, let's see, what are they doing down here? Speedometer. Radius. It seems a little too complicated. We're just going to maybe do a bit simpler of a whole calculation than this, but this is a generally helpful start. You can see they're actually doing the conversions from the RPM to the speed, which is kind of cool. So in order to get our RPM, I'll make another variable, and just so we can see what it's doing, we will make it a serialized variable called float RPM. So now we actually have to do some calculations for our RPM in our update method. So that person used RPM to get to speed, so we can use our speed to get to our RPM. So we'll make our RPM variable. And RPM is generally a pretty large number compared to our actual speed. So if you're going somewhere around, I don't know, like 80 miles per hour, maybe you get like 3,000 RPM or so. So we'll just say like speed. And in this case, we'll just create our own little formula. and just kind of show you a cool symbol that you can use. So if I type shift on the number 5, I get this % symbol. And just for the sake of seeing what it looks like, so speed %30. So the % symbol is a special kind of operator in C# and in programming in general called the modulus operator, or what you may be more familiar with, the remainder operator. And so this means that we are actually dividing speed by 30, and then it will actually give us the remainder value. So if speed were to be 30, and then we divide by 30, we actually get a 0. If we divide speed, which is 31, divide that by 30, we actually get a 1. And so this is just kind of a cool way that we can kind of wrap our numbers all the way from 0 to 29. So let's save. And in fact, we actually need to set this RPM in our RPM text. So we do RPM text, set text, M plus RPM. So now we save. Let's check out our project, see what happens when we press play. So now we should just see it go from 0 to 29, and then it goes back. So that's cool. However, 29 is definitely not a very high RPM. So we'll make this a little bit cleaner. We'll actually just wrap this entire little equation with parentheses, so that way this operation happens first, and then we multiply this times 40. Let's save. Now let's see what kind of numbers we get. Okay. It's kind of as if, like, when you're going through each of the different speeds, you're actually kind of shifting gears in a way, resetting the RPM back down every time. Cool. So what you're going to do is create a new text object for the RPM. Make sure to position it in the top left. Make sure to disable wrapping. And then in your player controller script, make sure to create a new RPM text variable as well as an RPM variable. Head down to your update method where you're going to create this little formula here, this little equation to calculate the RPM, and then just make sure to set RPM text to have that value. So that when you test your game in Unity, you should see that the RPM goes all the way up to about 1200, and then it resets back down, and then it goes back up to 1200 again, as if you're changing gears. Now it's your turn. Now that we have a mostly functional vehicle, there's one other big bug we should try to fix. The car can still accelerate and decelerate, turn and increase in speed and RPM in midair. So how do we make it so the vehicle only moves when it's on the ground? Once again, we'll head over to the internet to see if there's any solutions. So I looked up how to test if wheels are on the ground in Unity. And there's a couple of options here. There's Unity Answers, which is from a few years ago. Could work. There's one from 2005. There's the official documentation. We'll take a look at the documentation for now. So it says that there's just wheel collider. It's grounded. It's a Boolean that says if it's grounded. Indicates whether the wheel currently collides with something. That seems like it's good enough to get the job done. So first what we need to do is we actually need to get all of our wheels as references so we can actually track them. So I am going to create a new list of wheel colliders in my player controller script. So I need to actually assign these variables, so I'll serialize this. We'll call it a list. We need to make it a type of wheel collider. And we can name it all wheels so we can keep track of all of our wheels. So now that we've added that list to our player controller script, we do actually need to set the size of this list. In this case, we have 4 wheels, so we need to set the size to 4. And now we drag in each of our wheels as different elements. So that's the front left wheel, this is the front right wheel, this is the rear left, and this is the rear right. So now that we've assigned references to all of our wheels, we'll need to create a new variable just to see how many wheels are on the ground. We need to keep track of the number of wheels, so we actually need an integer. So we'll say int, and we'll call it wheels on ground so that we can keep track of the number of wheels that are on the ground. After our update method, we'll create a new method, in fact, to keep track of the number of wheels. So we'll call it void, and we'll just call it the count of our wheels. So we need to keep track of the count of our wheels on the ground. So we use wheel on ground. We set this to 0 because we'll assume that there are no wheels on the ground. Now, a cool thing that we can do with lists is something similar to the way that we used for loops to iterate through something before. So with for loops, you could set the end condition of when the for loop would stop. With lists, we can actually use the for each loop. So we type for each, and then we actually use parentheses. Now in our for each, we need to tell it what we're trying to find in our list. So we're trying to find wheel colliders. We need to give a name to that wheel collider. So we'll just call it each wheel that we go through. And now we need to give it the list that it's actually going to go through. So in all wheels. And then after this, we put curly braces. So now we're in our for each loop. So what we're going to do is if each wheel, and now we can use the is grounded attribute. So if our wheel is grounded, wheels on ground plus plus. So just to think about how this will work, when we call the count wheels method, it will go through each wheel in our list of wheels. So the front left, front right, rear left, and rear right wheel. So maybe it goes through the front left. That wheel is not grounded. It will not add a number to the wheels on ground. Front right, that is grounded, so it will add 1 to wheels on ground. Rear right, also grounded, so it will add another 1. Rear left, not grounded, so it will not add 1. So then we're left with 2 wheels on ground. The right side wheels, but not the left side wheels. Now this could be useful, however, what we're actually looking for is to know when our wheels are on the ground. We don't just want to keep track of the wheels on the ground. We actually want to know when our vehicle is entirely on the ground. So I'm actually going to change this method a little bit. So void doesn't actually give us any value back. So we actually need to return a value, and we'll actually return a bool. And instead of count wheels, we can just say is on ground. So now if I call the is on ground method, it should give us back a true or false. True if all 4 wheels are on the ground. False if none of the wheels are on the ground, if less than 4 wheels are on the ground. So now we're keeping track of how many wheels are on the ground. So we can actually just use another if statement. So if the wheels on ground is equal to 4, if all of the wheels are on the ground, we return true and keep doing whatever we want it to do. Else, we return false. So if less than 4 wheels are on the ground, then we don't want our vehicle to move. So now that we are keeping track of whether our vehicle is on the ground or not, in our update method, we should actually prevent the player from being able to move when they're not on the ground. So in fact, I can actually just wrap this entire statement here in an if statement. So if is on ground, parentheses here, delete this, put all of this in parentheses, in brackets I should say. So if is on ground returns true because all of our wheels are on the ground, then it will update our forces, rotate our vehicle, and give us the RPM. Otherwise, it will return false, and we won't be able to move our vehicle. So if I save this, pop back into Unity and press play, now I can move the vehicle, and then you can see that my speed and my RPM stop because I left the ground. So what you're gonna do is in your player controller script is on ground. So if is on ground returns true because all of our wheels are on the ground, then it will update our forces, rotate our vehicle, and give us the RPM. Otherwise, it will return false, and we won't be able to move our vehicle. So if I save this, pop back into Unity and press play, now I can move the vehicle, and then you can see that my speed and my RPM stop because I left the ground. So what you're gonna do is in your player controller script, you're going to create a list of wheel colliders called all wheels. In Unity, in your player object, under the player controller script, an all wheels variable should appear. Make sure to set the size to 4, and then make sure to drag each different wheel into each element. So the front left, front right, rear left, and rear right. Once you've done that, create another variable to keep track of how many wheels are on the ground as an integer. You're then going to create a new method that returns a Boolean value called isOnGround, where you'll set the wheels on the ground to 0 initially. You will then loop through the all wheels list by using a for each loop, and you need to use the syntax for each wheel collider wheel in the all wheels list. Inside of that for each loop, just do a check to make sure that the wheel is grounded, and if it is, to increase wheels on ground by 1. So that way, if the wheels are on the ground, all 4 of them, you return true, otherwise you return false. And then in your update method, you're going to wrap your place in your code where you apply forces, rotate the vehicle, and set the RPM into an if statement that checks if the vehicle is on the ground. Then you can do all these things. So then you can pop into Unity and test your game and see if your script worked. Now it's your turn.
And no, I didn't get it from prehistoric mud treatments. I don't put slimy eggs on it. I don't spend time in a bar pouring beer on it. I get it from my hair color, performing preference. Surprise! Not only do I get color that's translucent with layers of light, I get hair, beautiful hair, naturally fabulous looking hair. So I have everything. And I, for one, am worth